Hi, welcome to Expertizer Academy. This is Giri, lecturer in physics. In this video, we discuss about the moving coil galvanometer. See the definition of the moving coil galvanometer. Moving coil galvanometer is a device which is used to indicate the flow of current in an electric circuit. Moving coil galvanometer is a device which is used to indicate the flow of current in an electric circuit. So this is the definition of the moving coil galvanometer. Okay. So what is the principle? Moving coil galvanometer is follows. See this. When a current carrying loop is when a current carrying loop is placed in a uniform magnetic field, it experiences a torque. When a current carrying loop is placed in a uniform magnetic field, it experiences a torque. So this is the principle. Definitely at magnetic field there is any current carrying loop, it generates or it experiences a torque. So this is the principle to work moving coil galvanometer. Next, see the construction of the moving coil galvanometer. Okay. A moving coil galvanometer consists of a rectangular coil PQRS of insulated thin copper wire. Imagine there is any PQRS rectangular insulated coil. Okay. This coil contains a large number of turns wound over a light metallic frame. This coil contains a large number of turns wound over a light metallic frame. It is just because of a solenoid type. So what is the definition of solenoid? Current carrying wound behaves like a magnet. It behaves like a magnet. It is called solenoid. Here actually it is not a solenoid. That shape is similar to the solenoid. Okay. Here galvanometer having PQRS rectangular coil. PQRS rectangular coil. So here there is another coil which has number of turns or a light metallic frame. Okay. A cylindrical soft iron core is placed symmetrically inside the coil. The rectangle coil is suspended freely between two poles pieces of horseshoe magnet. Two poles pieces of a horseshoe magnet. So what are the elements in this construction of the moving coil galvanometer? There is a rectangular coil PQRS. Rectangular coil PQRS. And next in this we have number of turns wound. Number of turns means this is the circular shaped conductors. It contains the circular shaped conductors. Okay. Next, a cylindrical soft iron core placed symmetrically inside the coil. There is a cylindrical soft iron core. Next, the rectangle coil is suspended freely between two pole pieces of horseshoe magnet. Horseshoe magnet and also cylindrical soft iron core. Next, number of turns of wound. It is a circular shape conductor and also a rectangle coil PQRS. So these are the materials inside the moving coil galvanometer. See the structure outlook of the moving coil galvanometer. See this. This is the horseshoe magnets, north pole and south pole. These are the number of turns of current carrying coil. This is the rectangle coil. See this. This is the rectangle coil. Here, this is the meter scale. in circular manner, meter scale in circular manner. So this needle indicates the flow of current on the numbers in meter scale. For example, in this scale, we have the here zero thing, I mean zero value. Here this is 1, this is 2, this is 3, 1, 2, 3. There is a flow of current from north to south pole direction or clockwise. Just imagine there is a clockwise flow of the current in this galvanometer. This flow of current indicates by this galvanometer at one side, that is from this 0 point to 1, 2, 3, and this direction or flow of current is changed. If there is a change in flow of current in anti-clockwise, this direction of flow of current indicates in opposite way. Okay, so that is the main use of the galvanometer. So once this galvanometer reading shows the zero value, that is the null point of that coil. Okay, that is the null point of that coil. And also the circuit connections are very good, are correct. Okay, so this is the outlook of the moving coil galvanometer. Okay, see some more information in this moving coil galvanometer. The upper end of the rectangle coil is attached to one end of fine strip of phosphorus bronze, and the lower end of coil is connected to a hair spring which is also made up of phosphorus bronze. See this rectangle coil which consists at upper end, that is phosphorus bronze, and also lower end it is also having hairspring hairspring which is made by phosphorus bronze. Okay, in a fine suspension strip w, a small plane mirror is attached in order to measure the deflections of the coil with the help of a lamp and scale arrangement. Okay, the other end of mirror is connected to a torsion head T. So these sentences meaning is, for example, there is a any light in front of the galvanometer, you have to arrange the one of the mirror, that light opposite, that reflection light creates the plane mirror, reflection of light is creates the plane mirror. This measurement which is created on one of the coil, that is deflection of the coil with the help of the lamp. Okay, at the scale arrangement, we have another observer, that is one of the coil. This coil deflected by reflection in light from the plane mirror. So this is the small information about the galvanometer when light is placed in front of the galvanometer. Okay, so this is not main information, I mean this is not correct explanation for the galvanometer. Why? Because in this concept we discuss about only flow of current, how to measure the galvanometer. So this one indicates how to use the galvanometer. You have to find the deflections generated by the any other light in galvanometer. So that only purpose of these sentences. Okay, in order to pass electric current through the galvanometer, the suspension strip W and the spring S are connected to the terminals. So when you pass the electric current through the galvanometer, the suspension strip W and the spring S are connected to the terminals. So this is the inner look of the galvanometer. See here, PQRS rectangle coil is there. Here two forces are working. One is upward, another one is downward. Here this is the magnetic field's direction, this is the current direction. Okay, consider a single turn of rectangle coil PQRS whose length be L and breadth B. PQ is equal to RS, that is equal to L, and QR is equal to SP, that is equal to B, that is breadth. Let I be the electric current flowing through the rectangle coil PQRS. So this is the information about the construction and rectangle coil shape. This is not sufficient explanation for the work. Okay, working about the galvanometer. That topic is explained in next video. Okay, so thanks for watching this construction of the galvanometer. For more videos, visit www.expertiseracademy.com. Thank you.